Okay, and here we're going to have, this is an atom. Got it?
Yes.
Okay, so the center, the radius of this one will be considered as, okay. So if this is a center, and this is also the center, okay. So then its radius will be considered, the average distance between their nuclei divided by 2 will be considered as the covalent radius. And since there is an overlapping take place in this one, so we will consider this one that this is not the actual radius. Okay, actual radius of the atom is greater than the covalent radius. Got it?
Yes.
So let's move further here. We are going to have the next one is covalent radius. Okay. Now the covalent radius is actually, we can say, approximately equals to internuclear distance. Okay, internuclear distance, okay, divided by 2, okay, or we can say that bond length, okay. What is the bond length? Divided by 2. The two bond length means the distance between the two bonds, 2 nuclear divided by 2. Got it? Got it?
Yes.
And moving to the next part is, there can be so many radius, okay, and there can be so many types. One, considering the cases of covalent radius. So cases of covalent radius. Okay, what are the cases of covalent radius? So first of all, if I say that this is the case one is when the covalent radius in single bonded, when the, we can say that when the two atoms are actually bonded, okay, and two similar kinds of atoms are bonded together, like in hydrogen, okay, the two atoms are bonded together. So that type of bonds or that type of radius will consider it as, okay. So here we can say the covalent radius in single bond, okay, single bonded, okay, there's a single bond, and we call it in the homo nuclear atoms, okay. So here this will consider that this is the, since this is the radius, this is the positive charge, and this is the radius Ra, okay, and plus this is the center, and this is the radius Ra, and they are the similar, radius will be similar because the atoms are similar. Then the covalent bond formation will be equals to, when the covalent bond is formed, then they will overlap each other, and this is positive, and their centers, okay, the average distance between these two, okay, got it. So we can see that
Yes.
here, if the atom A, okay, we can say that this is this one, okay. So if I say that this is atom A, and this is atom B, so we can say the diameter of A minus A will be approximately equals to Ra plus Ra. We can say that it is approximately equals to 2 times of Ra. Got it? Got it? So,
Yes.
okay. So we can simply say here that dA minus A will be approximately equals to radius of A approximately equals to dA by A minus A upon okay, upon Ra, upon 2 square. Okay, so this is how we calculate the radius of the two homoatomic molecule. Okay, got it?
Yes.
Let's have an example over it. For example, if I'm saying that if bond length of H2 molecule is 0.74 angstrom, okay, then Cr, the covalent radius of Okay, covalent radius of hydrogen of hydrogen atom will be equals to. So if I talk about that, if the bond length between H atoms, between H2 molecules, if I'm talking about the bond length is given to you. So this is DHH method. This is the bond length, and this is actually equals to 0.74 angstrom. Okay, got it? Got it?
Yes.
This is represented as bond length. So we can say here that RHH radius of this one will be approximately half of this one. Okay. The radius of H will be approximately equals to bond length of HH molecule divided by, that will be 0.74 divided by 2, and you will get how much? 0.37.
Yes.
So here, what does it represent? So if I talk about this one, that the covalent radius of single bonded homoatomic molecule is equals to radius of A will be equals to, what is this? This is the bond length. This is the bond length actually, and bond length approximately equals to bond length. This represents the bond length. The bond length divided by 2. Got it?
Yes.
If I talk about the next one is, if I talk about the covalent radius in single heteronuclear atoms. For example, if there are two different kinds of atoms are there, so how can we find out the covalent radius? So we can say that covalent radius in single bonded heteronuclear atoms, okay, will be equals to, this is plus and this is Ra plus Rb, then so this is simple. Again, if I talk about this one, that what is the radius? So the covalent radius with single bonded. This is a single bond, but the atoms are heteronuclear atoms. Means there is Ra and Rb. The two different atoms are there. Okay. Then we can say that covalent bond length between A and B will be approximately equals to Ra plus Rb. Got it? Got it?
Yes.
Here it will be equals to, and they were that this is the bond length. This is the bond length. Bond length of A and B will be equals to radius of A plus radius of B. And if you know the radius of A, then you can calculate the radius of B also. But here we need to two unknown quantity should be there. Okay. Got it?
Yes.
Okay. Now if I talk about the CH bond length, okay. Now CH bond length in CH4, if I'm talking about the example for this one, if you take the example question here, that CH, the bond length, CH bond length, okay. CH H bond length in CH4 is 1.14 angstrom, okay, and CC bond length, carbon bond length in C2H6 is 1.54 angstrom. Then the covalent radius of H is Yes, calculate it, please. You have 2 minutes to solve this one, to this one now. Done this one? Done? Yes, you. Nina, done?
No, sir.
Try it. Have you tried it? So what is being asked? Asking the covalent radius of hydrogen. Okay. So what is saying actually? It's given that covalent bond length between C and H is given to you, and the bond length between CH and is 1.14 angstrom. Okay. And the bond length of CC is also given to you, and that is how much? That is 1.54 angstrom. Okay. Now you know that the covalent radius of actually the covalent radius of carbon, okay, of carbon will be equals to, tell me, that will be the CC bond length divided by 2. Okay, that will be the bond length CC divided by 2. Got it? And that would be approximately, because this is the homothermic molecule and we can easily calculate it by dividing by 2. Got it?
Yes.
So how can you write it? You can write it 154 divided by 2, 1.54 divided by 2. What you will get? What you will get? 77, 0.77 angstrom. Are you getting the point?
Yes. Yes.
What is the noun?
Now, what is being asked here is that, now it is asking that what is the covalent radius? So you know that the covalent radius between R and CH bond will be considered as, how much it will be considered as bond length between A and B. Okay. If I talk about this one, the covalent radius between hydrogen and this one will be equals to, tell me. Or if I talk about this one, the covalent radius between, the bond length between R and CH is being given to you. Okay. Now, what do you need to calculate? You need to calculate this one. Okay. This one you need to calculate. Got it? So if I talk about that DAB, when they are the heteroatoms are there. So what we do here is, we will write here the radius of A plus radius of B. We write it like this way. Are you getting this one? When we have hetero, the bond length of A and B, the bond length of A and B is being given to you, then what you will write here? What do you will write here? Tell me. You write radius of A plus radius of B.
Yes.
This is the formula that we were studying here. That the covalent radius, the bond length of A and B, heteroatom is there, so we will write RA plus RB. Got it? Got it? Now this has been given to you. This has been given to you. So if I talk about that, the bond length of CH bond is given to you. CH bond is given to you. Okay. And you have calculated so this will be equals to the radius of C plus radius of hydrogen. So this has been given to you. And this you have calculated. You can find out this one, the value of this one.
Yes.
Please find out. Please find out this one. Tell me what is the radius of hydrogen?
0.37.
0.37. Very good. So you know this the bond length of this one R and C bond is given. This is 1.14. Okay, and my is equals to RC is 0.77 plus RH. So you can easily be calculated. This will be subtracted and you will get RH is equals to 0.37. But should I move forward?
Yes.
The next we are going to have is the shoemaker formula. Shoemaker formula is a formula that we used here, and this was shoemaker formula. Okay. So what we are right here, this is A, B, this is the diameter. Sorry, the bond length of A and B is equals to radius of A plus radius of B. Okay, minus 0.09 into XA minus XB. Okay, so what is D? What is DAB here? So this is bond length. Bond length of AB. Bond. Okay. The second, what is RA? RA is the radius of A. Radius of A. What is RB? RB is the radius of B. Radius of B. And what is XA? Is the electronegativity of atom. Electronegativity of atom A. And what is XB? Is the electronegativity of atom B. Got it? Do this one. And I'm just going to have a question here. Which of the following molecule is used for calculation of covalent radius? Which of the following molecule is used for calculation of covalent radius of nitrogen Okay, so if I talk about that, if you want to calculate the radius of this one, nitrogen, how will you be able to calculate the radius of nitrogen? If I'm having first is N2, option second is N2H4, C is H2, N2O2, and fourth is all of these. So here, actually, when we calculate the bond of this nitrogen, okay, this is nitrogen is going to have triple bond. This nitrogen is going to have single bond here, like this. Okay, so if I talk about the nitrogen atoms, N2H4 we have H4. So one nitrogen atom make maximum 3 bond. So here the nitrogen atoms is bonded with single bond. So whenever we are just going to have single bond, the single bond is given the first preference. Here also the nitrogen is doubly bonded. So here the nitrogen is triple bonded. Okay, so we can consider this one that in N2O4 we will have like this, the 2N. Okay, then one O here, one O here, one hydrogen here, one hydrogen here. Okay, this is the positive, this is negative, this is positive, this is negative, sorry, this is negative. So here the nitrogen atom is doubly bonded, or this charge is shifted. For example, this double bond here, then this will be single bond. So here the nitrogen atom is doubly bonded. So always whenever we are just going to have a molecule which is going to have the single bond there, okay? So we'll give the first preference to that one. Okay, so this will be the correct answer. Got it? Are you getting my point? What I'm saying?
Yes.
So single bond more preferable. More preferable. Okay. Got it? Please note it down.
Yes.
Next, moving to the next part is, have you noted this one?
Yes.
Next says, calculate the covalent radius of carbon by using the following information. CCl, ClCl, got it? Next is electronegativity. Let me first write the information here, okay? That the CCl bond length is given to you, that is length in CCl4 is equals to 1.71 angstrom. The second is ClCl bond length in Cl2 is 1.98 angstrom. Got it?
Yes.
Next, if I talk about electronegativity of carbon is 2.5 and electronegativity of chlorine is 3.0 given to you. So you need to find out the covalent radius of carbon. Carbon you need to find out. So what should be the formula for this one? Tell me. Do this one by using symmetrical formula. Here the first option is 0.66 angstrom. The second option is 0.77 angstrom. Third option is 0.80 angstrom. And the fourth option is none of these. Using this formula, which formula will you use? Tell me. You will write that R. You need to find out the formula, the bond between Cl first. Okay, got it? Got it?
Yes.
So how will you find out? Here the bond length between CCl4 is given to you. So you have to find out the bond length between, what's the formula? A and B will be equals to the radius of A plus radius of B minus 0.09 into what is X A minus XB. So here you need to find out DCl is given RC plus RB, sorry, not C, RB. RC carbon for RCl minus 0.09 electronegativity of carbon, negativity of carbon minus electronegativity of electronegativity of negativity of chlorine. Okay, now put the value. This value is given to you. This value is also given to you. You can calculate it. You need to find out this value and this is given to you. Calculate it, please. Are you calculating?
Yes.
Okay, calculate it. You got the answer? You got the answer?
No.
So why you can what is the how can you calculate the value of R, radius of chlorine? So if Cl2 is homoatomic molecules covalent bond length is given to you, so what is the radius? So radius of Cl will be bond length of CCl bond divided by 2. So what you will write here is 1.98 divided by 2. What you will get? Tell me. 0.99.
Yes.
Okay, so now you know the value of this one, you know the value of this one, and you know the value of this is being given to you, that the electronegativity of carbon is 2.5 and the electronegativity of fluorine 0.3. So why you are facing problem in this one? Hmm. So you can do this one. This is very simple. You can do this one, that is 1.17 is equals to how much it is 1.171 is equals to 0.99 plus radius of carbon we need to find out. We have put this radius of chlorine. Okay, got it?
Yes.
Minus 0.09 minus 3.0. Okay, we have to keep in mind that who the element with electronegativity, which is with more electronegative element, okay, whose electronegativity is given to you, we have to put it as B. Okay, sorry, A. Chlorine, we are just giving the preference. Okay, got it? And Cl,
Yes.
and then minus 2.5. So what you will get here? You will get here 0.99 plus Rc minus 0.09 into 0.5. Okay, when you multiply this one, what you will get? 0.99 plus Rc minus, when you multiply 9 by 545, you have to put the decimals after 3 digits. Okay, that will be 0.045. Got it? So when you subtract this
Yes.
one, when you subtract this one, first of all, you have to add this one. Add this one, adding this one. What you will get? Tell me. RC of this one will be. So when you subtract from this one, you will get 0.99 minus 0.045. Okay. So you will get approximately 945. Okay. The same. 0.945. So right here 0.9 Radius of RC will be equals to, and these two you have solved. This is 1.17. This is RC plus 0.0945. Okay, and this will go to that side. You will get RC is equals to 1.71 minus 0.0945. Okay, sorry, not 0.0, not 0.0. Yes, I think this is a decimal here. Okay, so this is 945. Okay, then RC will be equals to 1.17 minus, sorry, this will get plus here. Okay, when it goes to that side. So you will write here. When you subtract it, you will get a plus sign here. Okay, plus this one. So when it will go to that side, it will become subtraction. And this will gives you minus of 0.945. So when you subtract it, so you will get the radius as 0.77 angstrom. Got it?
Yes.
Okay. Now we shall be moving to the next type of one. That is, let's do one more type of questions on this one. And now this you have to do, and you have to consider it by your own. Okay, got it? So we just consider the following. Consider the following bond length. This is CCl bond length in CCl4 is equals to 1.80 angstrom, and SiCl bond length in SiCl4 is 1.40 angstrom. Okay, in carbon chlorine bond, the bond length is this one. In carbon, in silicon, this one is bond length is this one. Okay, and if it is given that in silicon and carbon, if they are just making the bond, okay, bond length in SiCl4. So here in carbon and chlorine, if we talk about, okay, and then carbon and silicon and carbon, the bond length in carbon and silicon is actually SiC is 1.20 angstrom. There are three cases that are given. One is carbon and chlorine, the bond length is this one, and silicon and chlorine is this one, and we have silicon and carbon is this one. Okay, in this one. Got it? On the basis of the given information, bond length, okay, the covalent radius of carbon is, tell me, option A, if I'm going to give you 0.40 angstrom, the option B is 0.80 angstrom, option C is 0.70 angstrom, and fourth is none of these. Tell me which one is the correct. Wait, how will you do this one? Tell me, any idea? Yes, Lena. Any idea? How will you solve this one? Are you there?
Yes.
So, do you know how will you solve this one? Any idea? The following information, consider the following bond length is given to you. Okay, so how will you find out? Just try it. Okay, just I'm going to give you the hint here is that if you know that DCl, the bond length of Cl plus if you add these two, okay, Cl another Cl. This is also Cl. The bond length of silicon and Cl. Okay, so if I talk about that, the bond length of carbon and silicon, if I talk about, and the bond length of Cl in this one, if we talk about that, there are two different atoms only. Okay, got it? Bond length of carbon and chlorine and silicon and carbon. Silicon and carbon. Okay, so this is carbon, this is carbon. Okay, that is how much? This is given to you 1.80 plus 1.20. That will be equal to 3.0 angstrom. And how can you write the bond length of this one? The bond length of the two heteroatoms will be equals to the radius of carbon plus radius of chlorine plus radius of silicon plus radius of carbon. Got it? So here we are going to have the two times of radius of carbon here. The radius of carbon, got it? Are you getting this one?
Yes.
Two times of radius of carbon is equals to radius of silicon plus radius of chlorine. That will be equals to 3.20. Got it? Got it?
Yes.
And what we need to find out? We need to find out the covalent radius of carbon. Okay. Now, radius of, if you talk about this one, right? What is this? Carbon and chlorine and silicon. If I talk about this one, so you know that this is the bond length. Bond length of silicon with chlorine is equals to 1.40. And what is this? This is the radius of silicon plus radius of chlorine is equals to 1.40. Got it? Got it?
Yes.
Now this put that value here. You'll get radius of carbon will be equals to 3.0 minus this will go to that side and this value is 1.40. You have to subtract it. 2 times of radius of carbon will be equals to, when you subtract it from 3.0, you will get 1.60. When you divide it, you will get radius of carbon is 0.80 angstrom. So please copy this one and do it one more time. Okay. Do you get this one? How we do this one?
Yes.
Yeah.
Yes.
Okay. Now we shall be moving towards the metallic radius. What is metallic radius? Radius. So metallic radius is used for the atoms which is bonded by the metallic bond. Okay. So we can say that it is used for those atoms which are bonded with by metallic bond. Okay. So we can say that it is used for metal atoms only. Okay. It is used for metal atoms only. Okay. Got it? So if I talk about this one, okay. So what is metallic lattice? So whenever there is a metal, okay. So if I'm talking about that, this is a metallic lattice, okay. Metallic lattice. If I'm talking about this one, so these are the atoms. These are the metal atoms, okay. Got it?
Yes.
So these are the metallic atoms, metal atoms, okay. So if I talk about that, these are in the crystal lattice, and what is actually the metallic radius? If I talk about, so this is in the whole as a whole, okay. This is as a whole. So if I talk about this is the same that we are going to have. There are two atoms, and they are not overlapped. Here in the metals, they are not overlapped. Okay, the atoms are not overlapped. Like in covalent radius, the metals are overlapped. Here, the metals are not overlapped. Okay, so if I talk about the metallic radius, here is, so this is the metallic radius. This is the metallic radius. Okay, got it? Got it?
Yes.
So if I talk about this one, that half of the internuclear distance between the two nuclei of two similar atoms, if you are talking about the two similar atoms bounded by, they are considered to be as, means if they are bonded with metallic bond, then the half of the radius or half of the distance between the two centers will be considered as metallic radius. Okay, got it? So have
Yes.
you drawn this one?
Yes.
Okay. So what about this one is half of the internuclear distance between center of two nuclei of two similar metal atoms bounded by metallic bond. And here in the previous one, actual radius was greater than the covalent radius, but here actual radius is equals to the metallic radius. So please note it down. Done.
Yes.
So we can say that metallic radius is actually equals to the internuclear distance and divided by 2. Got it? So for example, if I talk about the internuclear distance, so example, so internuclear distance between two potassium atoms in a metallic lattice of potassium. And metallic radius got it.
Yes.
This is the metallic radius, so it is simply divided. Okay, next is van der Waals radius. Done this one. Should I move forward?
Yes.
Next is van der Waals radius. What is van der Waals radius? Van der Waals radius means is the radius or the distance between the two atoms which are attracted by van der Waals force. Okay, got it? Which are attracted by van der Waals force. It is the force. It is not the force between the two atoms. It is the force between the two different molecules. Okay, got it? The distance between the two molecules. If I'm talking about it. Okay, so we can say that it is used for the atoms which are attracted by van der Waals force. It is used for those atoms which are attracted by van der Waals force. Okay. Non-metal atoms. Okay, it is used for inert gas, first of all. And if we're talking about the non-metal atoms, like for example, if we have a hydrogen gas filled in a cylinder, we can have a particle. Okay, so if this is hydrogen gas, one hydrogen particles are there. Okay, there are so many hydrogen particles are there. So if this is the hydrogen gas that is filled here, H2 gas. Okay, so if I talk about what is H2 gas, so if one H2 molecule is attracted by the another H2 molecule, so the distance between these two molecules is considered to be as van der Waals force. Okay, the force here between the two different atoms is considered to be as van der Waals force. Got it? Like in helium, He1 helium atoms, we have another He helium atom. So this is also considered to be as van der Waals force. Noted?
Yes.
Should I move forward?
Yes.
So what is van der Waals radius if I talk about is that if we have the two H2 molecule, like one H2 is there, another H2 atom is there. This is the H2 molecule because there is a covalent bond between the two H2 atoms in H2 molecule. Okay, and this is another one. Okay. So if I talk about that, what is van der Waals radius here is that is the distance between the two closer nucleus. Okay. And half of the distance between them. This is known as van der Waals radius. So this is van der Waals radius. Got it?
Yes.
So actually, it is not the actual radius. Okay, this is the distance between the two different atoms. Okay, so we can say that it is not an actual radius. Actual radius. We can say that actual radius is very less. We can say very less than the van der Waals radius. Okay, we can say that this is very small because this is very far away. No? The two molecules are very far away. Got it? Got it?
Yes.
And it is calculated only in the solid state. If I talk about this one, that note, you need to find out that it is always calculated in solid state. Okay, not in the gaseous state. Solid states. Okay, we need to. So relationship between, if I talk about the covalent radius and the van der Waals radius of a non-metal, what is the relationship between the covalent radius and the van der Waals radius? So note it down. Relationship between the covalent radius and van der Waals radius. Wall radius of a non-metal. Done? So that is, we can say that 2 into covalent radius is approximately equals to. Yeah, we can say that covalent radius is approximately equals to van der Waals radius divided by 2. Got it?
Yes.
And you know that covalent radius is actually equals to half of bond length. Half of bond length, you know this one. So if we match this one in terms of bond length, you know that covalent radius is equals to bond length divided by 2, and that is also equals to covalent radius is also equals to van der Waals radius divided by 2. So this 2 will cancel out. We can say the bond length is approximately equals to van der Waals radius. Okay, van der Waals radius. Note it down, please.
Done.
Done. Okay. Okay. Now, if I talk about that in a diatomic molecule, actually, if sometimes you know that bond length here is approximately equals to van der Waals radius. So if I talk about the homoatomic molecules, okay, or homonuclear atoms, or homonuclear diatomic molecule, homonuclear diatomic molecules. If I talk about this one, okay, then we will say that in homonuclear diatomic molecule, okay, bond length, you know that bond length is actually equals to is approximately equals to, or we can say that bond length is approximately equal to van der Waals radius. Van der Waals radius. Got it? And
Yes.
when we have a numerical on this one. So for example, if I talk about this one, for example, we know that bond length of H2 molecule is 0.74 angstrom. So if it is a bond length, so if I talk about the what is the van der Waal radius. Van der Waal radius is also approximately equals to 0.44, okay, of hydrogen. So bond length is equals to van der Waal radius of hydrogen. Okay, got it? Got
Yes.
it? So if I talk about this one, that if we have a question on this one, that in internuclear distance between center of two nuclei of two I atoms, okay, adding atoms of two adjacent solid I2 molecule is 1.80 angstrom. Okay, then V R of I atoms